that a yes? I got my stuff? Chris?
What are we doing on Monday?
We're gonna finish this up. Okay. Is the calendar done? Is there a new calendar?
No, we got it.
Okay. So you have it. Yeah, I'll record all this. It's recording right now. Okay. All right, you guys ready? I had 10 minutes to spare in period whatever, 5, so I think we're okay. We'll get through this. There just won't be much time for us to work together.
Don't forget to record.
Isn't it recording?
Yes. Little thing, little black dot. Yes.
Yeah, right there. That's yeah, right here. Black dot recording. Okay.
Yes.
Okay, guys, here we go. Your job today is to make what? Transformations, yes. So transformations of graphs. Of what graphs? The parent graphs, right? This is the quadratic. And then this one that starts here and goes square root, and then this one that goes like this. Greatest integer, and then what else am I thinking? How about this one? It kind of okay. That.
Identity.
That's cubic. Up, and keep going, right? There's probably some other ones. Give me one other one. Oh, constant. I'll do this one. And identity looks like what? Tilt me. Goes right to the origin. My chest is the origin. Okay. What else? Reciprocal is a hard one for me. Okay, it'd be this, and then it'd be this way, and then it would be right? Yeah, like that. Okay, you take all those parents and do what to them? Shift it. Right, left, up, down, okay? And that would be the easiest transformations to make. Because all you have to do is add a number to x, or subtract a number from x or y. Okay, so let's just quick talk. If you have a function, f of x, okay, and let's just pretend it's the quadratic one because it's easy. Okay, if you open the parentheses and you stick a number inside, okay? So, for instance, like that, right? Or if you have x plus h or x minus h, then it shifts the entire graph what? Horizontally x or h units, okay? In the what direction?
Opposite.
That's weird, opposite. So when you see x plus h, am I going that way, h,
No.
or that way? You're going left, h. When you see x minus h, seems like you're going backwards. Nope. You're going to go forward h, correct?
Yes.
Okay. So when you look at this one, that isn't that the parent right there? Because it's x squared. They opened up the parentheses, they stuck minus 3 inside. You would say this is what? What kind of transformation is that? It's a horizontal what? Horizontal shift. How many? 3 to the right. There you go. Okay. Horizontal shift, 3 to the right. Because it's just weird how minus 3 inside means go right. But if it would have been a plus 3, you would have went left. Okay. Really quick, if I did this, I know the parent looks like this, right? Off again. Okay. Parent looks like that. Yours will do what? Go 3 to the right. 1, 2, 3. Yours will be the same thing except like this. Correct? Now, what just happened to all the points on the parent? 3 to the right, but what happened to the, let's say, here's the parent, here's x, here's y. What really happened to these ordered pairs? You went 3 right, so which one got changed? X got changed. What did you do to it? You added 3. You took every x value, you added 3. Or if you were on graph paper, what did you really do? You counted, didn't you? Here I am. There I am. Okay, you just count. But when you talk about points, you just really took the x value, you added 3, and you left the y value all by itself. Okay? That's it. But if you don't put it inside parentheses, you actually just do this. Now I kind of have to erase that because you can't see it. If you take the parent function and you just put plus k back on the backside or minus k on the backside, now it becomes a vertical what? A vertical shift up how high? K units or down k units. It's exactly the same direction you would think. When you see plus, go up. When you see minus, go down. This one is exactly the way you think. So if you look at that one, you're thinking, I'm hoping you're thinking, x squared is your parent. There's your parent, and you're going to do what? You're going to vertical shift what? Up 5. So if this is your parent, I'm doing this really quick, you're going to go where? 0, 0? 0 what? 0, 5. And all of these points are going to go where? Up 5, up 5. So you get the same graph, just 5 units higher. Right? Okay. I know you know this, but I'm going to say it anyways. This is on your parent. It's x, comma, y. But when you said up 5, what really happened to every point? You added 5 to what? The y. So if you vertically shift something, you add to the y. Or you subtract from the y, whichever way you're going. Okay? Okay? See this? Two things are happening. What two things? That's what? That's horizontal shift, what? Left 7, then what? Vertical shift, down what? Down 2. If you think of your parent, here's your parent, that's your parent, xy. What are you really doing to all these points? What are you doing to the x? 7 away. What are you doing to the y? Minus 2. That's really what you're doing. But that's what's going on in your head. You're going, wait a minute, where does 0, 0 go on this one? Well, it would go where? Negative 7, because 0 here, 0 here. Negative 7, negative 2. But to me, if I'm graphing this, I'm going like this. Left 7, down 2. There it is. That's what I'm doing. And then I kind of know, at least I hope you know, the first point is over 1, up what? Up 1? Well, guess what? Over 1, up 1. The second point is over 2, up what? 4. You're going to do what? Over 2, up 4. So you can kind of see it. It's right there, right? Okay. So these are called vertical shifts or horizontal shifts, right, left, up, down. Okay? Okay. This is us practicing number 12. It's the worksheet. But you're not ready. I haven't told you enough, so we got to keep going. Go to the next one. Transformations of graphs. Oh, you know what? I was going to shut the program off and see if it fixes my pen. But if I shut the program off, the recording's off. So forget it. Sorry. We're just going to have to live with this. Okay, so now what happens is they do call this stuff rigid transformations, which basically means your parabola, your v, your square root function, all that stuff. The shape of it just moves over. The shape never changes. Up, down. I can reflect things. I can reflect. The shape never changes. That's what a rigid transformation is. Just move it around. Okay, so what happens when we do this? You take your function and you change x to what? Negative x. Okay, so there's your function, f of x. And it looks like to me we're modeling which one? Which parent? The square root function, right? So that's your parent, and look what they did. They took your parent, and instead of writing f of x, they wrote f of. When we switched x to negative x, weren't we checking for symmetry? Over what? The y-axis. When you switch x to negative x, you're checking for the y-axis. Okay, so if this is ever the case, it is a reflection of the parent graph over the y-axis. Okay. So when I look at this problem, I mean, when I see f of x becomes f of negative x, that's what they're talking about. If you go inside your function, inside, and you switch x to negative x, you are reflecting over what? Y-axis. So quick, help me out. Do the parent right now. Give me points. 0, 0 is the easiest point. Don't ever skip 0. 0, 0. Now what? 1 what? 1, 1. Now what? 4, 2. Yes. Next one? 9, 3. Okay, this is the square root function. That's f of x. That's the parent. You don't have the parent. You have what? You have the parent reflected over what? Over the y-axis. If you go inside the function, you switch it to negative x, it's over the y-axis, over y. So, if it's over y, then 0, 0. Reflected over y, guys. Where's it going to go? It's not going to go anywhere. Where's 1, 1 going? Well, no. Not
Negative
1,
one.
negative 1. Oh, this is over y-axis. My fault. You're right. You're right. It'd be this way, wouldn't it? Oh, that's x. Jeez, you had me messed up there. Sorry. Let's try that again. Over the y, right? Over the y, this way. Okay, where's this one going to go? 4, 2.
Negative 4, 2.
Negative 4, 2. Where's this one going? 9, 3.
Negative 9, 3.
Negative 9, 3. There you go. Reflection over y happens when you go inside your function and change it to negative x. So would this, hey, would that be a reflection over y? Did I go inside the cubism and switch it? Yeah, I did. That's a reflection over y. So when's it a reflection over x? When you put the negative in front of the function. Okay? So you see this right here? Isn't that your parent? The absolute value of x. Now when they stick it in front of your function, now it's a reflection over x. Okay? So let me come down. What is, oh, I missed it. What does that do? Reflects over what? Reflects over x-axis. And by the way, you will get a lot of these on your assignments, a lot of these on your test, okay? We don't usually reflect over y. We do sometimes, okay? So now, what does the parent look like here, guys? The absolute value of x. What's the parent look like? Right here. Now we go like this. F of x equals absolute value of x. What does that look like? A b, starting at 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 4, all that, right? So it's a b, going this way and this way. But yours is a reflection over the x-axis, so it's going to be upside down, yeah. Okay, so it goes this way. And there's your reflection over the x-axis. Good? Okay. Hey, just a question. What if I would have reflected it over, what if I would have reflected the parent over the y-axis? Here's the parent right here, f of x. Flip it over y. What's it look like? The same thing. Sometimes that happens. You reflect it and you go, well, that's the same thing. Yep, you're right. Which just means what? It's symmetrical to the y-axis. So if you flip it over y, you get the same thing. Okay? Okay, try this. This is just a quick example. Let's do, use 5 points to draw the parent. That's the parent. Go draw it. I probably would put it somewhere around here. And I hope you're not plugging in. I hope you know them, right? So 0 goes in, 0 comes out, 1 goes in. 1 comes out, right? 2 goes in, 4 comes out, right? Okay, And it is a parabola. It's symmetrical over the y, so it's here, and then it's here. So it's just like that, right? Okay. Now, looking at what you have actually two things going on. You have this inside and this on the outside. Now, what do you do first when you do transformations? Should I do the inside and then the outside? Okay, why? Think of order of operations. That's what I always say. Because kids always say, what do I do first? Do the order of operations. If you threw a number in, wouldn't you work inside first? And then you go outside? Well, that's exactly how you treat your transformation. So what's this do? Which way? Right? Okay, right 3. And then this little tiny, I keep doing that. That negative does what, guys? If it's in front of the grouping symbols, it's going to reflect over x. Okay? Reflects over x. X-axis. Okay? Reflects over the x-axis. So if I'm tackling this problem, I take every point and I go right 3 and then what? Over the x. So look here. I don't think you have to do much to these coordinates. Just look at it. Where does this go? Right 3. 1, 2. There's 3. Now reflect that point over the x-axis. You're right on the x-axis. How do you reflect over x? You don't. You can't. It's right there. The vertex is still right on the x-axis. Now, what about this one? Right what? 1, 2, 3. You're over the x-axis by 1. Now you're under by 1. This one. 1, 2, 3. You're over by 1. Now you're under by 1. See it? Okay. And then, of course, I can't do this one because I run off the grid. But if I do this one, it's 1, 2, 3. I'm up 4. Now I'm what? Now I'm down 4. So you can kind of see it like this, right? The other one would be about right here. Okay? Yeah? Okay. That gets confusing. What do I do first? Start inside your grouping symbols, then move outside your grouping symbols. So now, here, now that I said that to you, tell me this. X minus 7. Let's do another squared, and let's go negative here and a plus 6 there. What's first? Okay, but what do I do first? Say it. Right 7. What do I do next? This or this? Order of operations. You do this. Do you add 6 or do you multiply by negative 1? Yeah, multiply next. So this means what? That's a reflection. Reflect over what? Over x, axis. Okay. And then finally, this is last. Up, down, which way? Up 6. So this is the order you'd go in. I'm not going to do it, but that's the order you'd go in. Okay. Non-rigid. Okay. Non-rigid. Okay. So that's when you get done, your graph does not look like the parent. So here's the parent. Ready? That's a parabola. Okay. So what are we going to do with the parabola? We're going to vertically or horizontally, but for now, vertically. Vertically stretch it or compress it. What does vertically stretch it mean? Grab my wrist and stretch me. Which way do you stretch? See, some people say stretch me this way. Some people say stretch me this way. Well, stretch actually means make me farther away from the x-axis. So you want to stretch me which way? What does it do to the parabola? Makes it thinner. Okay. What does a compression do? Yeah, you're going to pull me down and make me closer to the x-axis. So it makes me wider. That's vertical. Now let's talk horizontal. This is getting weird. Okay, horizontally stretch me. Not this way, not this way, this way. Horizontally is this way. So stretch me would be what? Stretches always make me farther away from something. It's the y-axis. Here's the y-axis. Stretch me would be hold me away from the y-axis. Oh, it's wider. Compress means what? Push me towards the y-axis. So now you're making me thinner. Aren't they kind of opposites of each other? Did you catch that? That's why it's weird. It just is. I think I'm going to start with you guys down below. I'm going to do the one on the bottom. Because this one makes more sense to you guys. Because you actually did it quite often in Algebra 2. Okay, ready? This is a stretch or a compression. And it's vertically. So you're going to vertically stretch or compress it. Okay, so what happens is you take your parent right here. And you put a number in front. What's the number? Well, yeah, it's 2. But here it's just what? K. So you will stretch or compress vertically by a factor of K. Whatever that number is, you will multiply your y coordinates by what? K. All right, your K in your case is what? 2. You're taking the cubic function and you're going to, is this going to be stretch or is this going to be a compression? How do you know? Because it's a whole number. Actually, what you're supposed to say is it's a number greater than 1. If it's bigger than 1, it stretches it. Because what this does is it makes your y coordinates bigger. Okay, so let's take the parent. Here it comes. The parent is 0, 0, 1, 1, 2 what? Okay, so I'm doing the cubic function right now. 2 what? 8. Okay, so 2, 8 is here. Okay, and then on the other side is negative 1, negative 2, what? Negative 1, negative 1, negative 2, negative 8. Okay, there you go. And it goes like this. Okay. That's the parent. Problem is you don't have the parent. You have the parent. Now because that number is bigger than 1, you have it. It's going to be what? Vertically stretched, because it's bigger than 1, by what number? By factor 2. Okay? So, to me, this is a vertical stretch by factor what? By factor 2. Okay. Well, how do we do it? It says right here, multiply all your y coordinates by what? Multiply y coordinates by what? By what's k? 2. So really take every one of these points on this graph, take all the points, multiply the y by 2. That's what you're thinking in your head, right? Okay, ready? Let's do it. 0, 0 would become 0 what? 0, 0. It doesn't move. That's not much of a stretch, is it? Okay, but what about 1, 1? 1, 2. So stretch means make it farther away from the x-axis. 1, 2. What does 2, 8 become? 216. Way up here. 216. So this thing kind of goes like this now. You are stretching every point farther away from the x-axis. Okay. On the flip side, this negative 1 would become negative 2. This negative 8 would become negative 16. And there it goes. That's a vertical stretch. You're making all the points farther away from the x-axis. I'm not going to do it, but what would this do? That's going to compress the whole thing by what number? By factor 1/2. Which means all the y values get what? Closer to the x-axis. How much closer? Half. So that would be 1, 1 would become 1 what? 1/2. Negative 1 would become negative 1, negative 1/2. You get what I'm doing? 2, 8. 2, 8 would be what? 2, 4. And, of course, negative 2, negative 8 would be negative 2, negative 4. So now the graph does this. There it goes, there it goes. So that's 1/2 x cubed. Yeah? Did all the points get the distance from the x-axis to the point, is it half of the distance? Yeah, it is. I don't know if you see it, but it is. Okay, that's not the confusing one, I don't think. I think the other one's a little more confusing, and that is, what kind of stretch? Horizontal. You did not do this last year. I don't think you did this in Algebra 2. When do we see this happen? When you take the parent and you stick the multiplier where? In front or inside? Inside. Okay, so here it is. Kx. There's your multiplier k. Now read this because this is confusing. This is either going to be a stretch or a compression of the graph, or the graph of f of x, horizontally by a factor of what? 1 over k. It's not, the factor is not k, it's 1 over k. So you multiply your x coordinates by 1 over k. Okay, watch this. This is a horizontal stretch or compression. What do you think? You think it's a stretch? How come? It's greater than 1. Problem is, this is why it's weird. It's a compression. When it's bigger than 1, it ends up being a compression. When it's smaller than 1, it ends up being a stretch. Okay, so what do you do here when you see this? It's a horizontal what? 2 is bigger than 1, but this is the opposite of what you think, so it's going to be a what? It's a compression. To me, that just means, it makes everything closer to the y-axis. Okay, so what do? We multiply all the x coordinates by what?
1 over 2.
1 over k. You've got 2 here, so by factor what? 1/2. Does that make sense? Let's just do it and see if it makes any sense. Ready? I'm going to just go to a new page. So the square root of x is our function, our parent. It goes like this. Isn't that it? Well, I'm doing my best. 1, 1, 4, what? 2. And of course what? 9, 3, somewhere in here. Okay. What you have is what? You don't have this, you have what? Yeah, so that's a horizontal. It is compression. It's the opposite of what you think. Horizontal compression. Okay, by what? 2 halves. To compress means you have to multiply by a number smaller than 1. Okay, so then you take every x value or y value. Which one is it again? Yeah, if you're going to compress horizontally, it's x. X moves you in and out. So go half. All right? Now tell me, 0, 0 changes to what?
0.
Yeah, it doesn't move. It doesn't move. 0, 0 stays 0, 0. What you're doing is you're making all the points, you're compressing them closer to the y-axis. What's half the distance from here to here? Yeah, wouldn't it be 1/2? So this is going to end up being 1/2 over a half up 1. Did I confuse you? Okay, remember, this is the point I looked at, 1, 1. Where does 1, 1 go? Half of 1 is 1/2 over up 1. Just move it in a half ways. Okay, this one is what? 4, 2. You're going to take half of that number. What's it going to be? 2, well, that's bad 2, but 2, 2. Okay, that's 9, 3. Where's 9, 3 going to go? Compress it. Push it in. Where's it going to go? 4.5 would be somewhere in this area. 4.5, comma 3. That is right there. That is a horizontal what? Compression. It's like you grab it, you compress it right back into the y-axis. So what does a stretch look like? You grab the black points and do what? Pull it away. So if I gave you a stretch, it would have to be what? Give me something.
1/2.
1/2. Okay. You just gave me a number less than 1. Seems like a compression, but it's not. It's a what? It's a stretch, which means you multiply all your x values by what? 2. Which would make 9, 3, what? 18, 3. Way over here. Right? It would make 4, 2, what? 8, 2. You know? Horizontal stretches and compressions. Pull it away from the y-axis or push it towards the y-axis. Okay? Okay, I think I'm done. That's, right? Yeah. Hey, go do number, let's go right here. Okay, let's take a look at this. It says use the graph of f to sketch each graph. Let's not pick A. A was too easy for period 5. So let's pick something else.
G.
G? Okay, what is G?
G is F of 2x.
F of, like this?
Yeah.
Okay, all right, and I gotta know the points again, help me. I know it's
Negative
Negative 4, 2, negative 2, 2.
negative 4, 2?
Yeah.
Okay, here,
Negative 2, 2.
negative 2,
Negative
negative 2.
0, negative 2.
0, negative 2, yep,
6, 2.
6, 2. Okay, I think this is it. In number 12, they tell you to copy this 7 times and transform it 7 times. So I did it for you. I gave you the function f of x. Now, this is G. They changed your parent. This is a weird parent. This is your parent, and they want you to do this little thing to it. They went inside, they multiplied x, your function, by 2. What is this? Is this a vertical stretch? Or is this a horizontal? Vertical would be in front of your function. That's vertical. When it's inside, it's not vertical. It's what? It's what? Horizontal. Okay, so we would say what? We're going to say horizontal. It's either a stretch or a compression. This is the opposite of what you think. If it's bigger than 1, we usually say stretch, but it's not. It's what? It's a compression. By, what's your multiplier? If you compress, you make it smaller. It can't be 2. 2 makes things bigger. 1/2. This is the weird one. You picked the weird one. Okay? Okay, so what do we do with horizontal compressions? We take every point on the parent. We take every point on the parent and do what to it? If you're going to compress it this way, what's being controlled? The x's. So you multiply all your x's by what? 1/2. That's it. That's all you do. And if you look at your x values, which I wrote, I didn't write this one, did I? Oh, I didn't write anything. Negative 4, 2. Where's negative 4, 2 go? Compress it. Push it towards y-axis. What's it going to be? Negative 2, 2. Right? Okay, what's this one going to be? This is negative 2, negative 2. Cut that in half. Negative 1, negative 2. So it goes from there to there. Now, compress that thing. That's 0, comma what? Negative 2. Multiply 0 by 1/2. What do you get? It doesn't change. How do you push a point closer to the y-axis if you can't push it? All right, it's right on the y-axis. Okay, so there it is. And now, move this one in halfway. Would that be 3? So this thing goes boom, boom, boom. Think about it. Did we do this? Did we go like this? Compress it in by 1/2? Yeah, we did. That's all it was. Horizontal compression. Okay, did you guys hear Zach? Zach said it was a vertical. Well, vertical only happens when you take your function, f of x, and put a number where? Out here. If I put in 1/3, is that a vertical stretch or compression? That's a compression. That's exactly what you think. Less than 1, compress. Bigger than 1, stretch. What do you multiply? 1/3 by what? What controls vertical?
Y.
The y. Take every y times 1/3, which would make it what? Closer to the x-axis. You see what we're doing here? Okay. Not as easy as you think. Some people, like period 5 looked at me like, yeah, it's easy. And they went, no, it's not. I don't think it's easy. But I always find it amazing. Like halfway through the year, I start talking to you guys and you go, well, that's just a vertical stretch, and that's just this, and this. And you just, bam, you just grab these things so quick. And really, I can't do it that quick. Some of you are going to be a lot better than me. So, And some of you will struggle all year with this. It's not easy. Where do you feel like you're at? Scale of 1 to 10. This is 10. That means I think it's so easy. This is 1, and that means I think I'm about ready to cry. Where are you at? You see him?
I mean, we're being honest.
Just be honest. Yeah, I don't care. You say 1.
I'm just always ready.
And most people are above a 5, and I'll take that on day 1. I mean, I think by day 3, I'm hoping everybody's at least a 7. Okay. And by the middle of the year, I hope you guys are all 10s and you're just going, that's easy. Move it right, move it left. Okay. When should you do this assignment? Well, I don't think I do it tonight because you're supposed to be good at what tomorrow? 1-1 to 1-6. 1-1 to 1-6. Okay? Don't do it tonight because you're probably going to confuse yourself a little bit. Okay? Don't do your homework tonight, I said. I didn't say at all. Okay? Save it for this homecoming weekend. Yeah, when you're at the dance.
Yeah, do your homework at the dance.
There you go.
Doing your eyes is terrible.
Okay, hey, I'm good up to 90. Tennis players. 90 and 106 are up here, just so you know. Want to take a picture? Take a picture. Want to show up at school? Show up at school. No, you study. Anybody get a 1-5, 1-4, 1-6, 1 anything? Anybody got late?
You want us to turn it
No. I'm saying late. Oh, the book here is. And yours? Okay, what did you think? You okay with it? Okay, you guys? That's weird. Weird or is it okay? You okay with it? You too? See you tomorrow. So did you already start?
No, I'm finishing it.
Okay. You're starting them, huh? Okay.
I'm just finishing.
Oh, okay. Do you have any questions? No. Nothing? It's all easy for you?
Yeah, I think so. As long as I'm doing
I'm just gonna look. Did we do this one together?
No.
So that one is a reflection over the y. Yep. So then 6-2 becomes negative 6-2. This becomes 4-2. Yep, that's good. And this one is b plus 4. Plus 4 means up 4, right? This up, yeah. And c.
I accidentally did them like this way.
Oh, 2 in front of the function is a stretch. All y values get twice as high, right?
I did.
So all y values get twice.
Yeah.
So when you said 2 and you went to 4, good. When you said 2 and you went to 4, good. But this one's down 2.
Right.
So now it should be down 4. Down 2, down 4.
Okay.
So you pull them away from the x-axis, right? Haven't done that one. Did it again. We did this one together. Okay. Pretty good, pretty good. Hey, how you doing? Pep rally in just a few minutes, right?
At 2.
Starts at 2, so they should be calling people down pretty quick. Okay. Still okay?
For relative minimum and maximum, is it coordinate points or is it just like one?
Points.
Okay.
It's just points, like over 3 up 10
Okay.
is a point.
Just have one last question.
Yes.
It's like that.
Okay.
Where's the finding if this was odd or even?
Oh. Okay, so we want to check for what? Even maybe?
Yeah.
Okay, even. Even means over the y-axis, right? Okay. So that means you switch x, right? And when you switch x, what they say is going this. F of negative x instead equals f of x. So if you switch x, you should get the same function of x, right? Okay, so f of x is right here. So when we switch the x, it becomes this. Fifth root of 6 times negative x squared. But what's negative x times negative x? Yeah, so x squared times 6 is
6x.
and does that equal this?
Oh, yes.
Yes. So it is symmetrical over the y-axis. Okay, but if you were doing the origin, okay, which is odd, right? Then everything's the same now except the 6. Right? And we already know the answer to this is this, right? So, okay, what would the answer to this be? Is that the same? Nope. Whatever you get out of this, let's say you get 10. Well, this is negative 10. It's not the same. It's even, which means it's symmetrical to y. That's all it is. I will be honest with you right now. This symmetrical stuff, they're not going to talk to you even. They're not going to say it on the test. They're just going to say test for symmetry. Well, how do you test for symmetry?
Check the x.
X, y, and origin. X, you flip y. Y-axis, you flip x. And it will be written that way too, with x's and y's. It won't be written in function notation. So it's much easier than you think. Okay. Hey, Gage, can you grab my book? Actually, both books, I guess. Thanks.
Get your Reese's cup. It's been sitting there since I've been here.
What's that?
So you gotta get your Reese's cup. It's been sitting
I had one yesterday, and I went home, and it's so sugary. I don't eat candy very often, and it's good. But as soon as I eat it, I'm like, you want it?
Sure.
Take it. And then I don't have to eat that stuff.
Oh.
And I'll eat it. I'll eventually eat it.
Thanks.
Yep. It's all yours. Don't get sick.
Thanks, yeah.
All right. See ya. See ya.